Hi, can you hear me online?
Yes.
All right, awesome. Okay. All right. Hi, can you still hear me?
Yep.
Still hear me?
Yeah, I can hear
All
you.
right. All right. All right. Let's get started. All right, welcome everyone. I think we have a quiz at the beginning, right? Yeah, let me get this started. Let's see. So that's Q3 querying, right? Do you all see it? Okay. And the password is actually, let me turn off the password. There we go. Okay, password is off, so you should be able to start it. Online, folks, the quiz is available. It has no password. You can start anytime. Oh, why is it like so dark here? Again, it's an open book. If you look at the slides. If you have to fill out a word that's two words, like group by, make sure it's two words, not one. So if there's two fields, then put the one in one field you put group, and in the other field you say by. Okay, don't put it in one single field. Doesn't matter, right? Capitalization. No, that's
Professor, I have a question.
yes.
Would you want us to put in like the PK, the open parentheses PK close parentheses in there for the primary keys, or do you just want the primary key itself?
Yeah, don't use the PK nomenclature. That's only to let you know that's a primary key.
Okay, thank you.
Yeah, in the questions, I added PK and FK just so you know that that's a foreign key or a primary key. Don't actually use that as the name of the field. Okay. No, it does not.
Reading it wrong. They all have something wrong with them. All the options have something. Like,
Yeah, the only one of them is obviously the right one.
yeah. Okay. I feel like I found something wrong in it.
No, there's one that doesn't.
Okay.
Well, unless I did it wrong.
Well, I'm just confused about like I've never like the select statement looks right, but I've never seen it written like this or like this and then like this.
Well, this is the renaming of the table, so you use an alias name. Okay.
Oh, so that's you renaming it.
Yeah.
Okay.
Yeah, we've seen that in the slides quite a
Yeah.
bit, right? Where we choose another name, a shorter name.
Oh, okay.
Yeah.
I was confused. Sorry.
All right, who's done? Wow. Okay. Who's done? Who's not done? Okay, done? All right, one more time. Who's done? Who's not done? All right, couple more minutes. All right. Let's get going. All right, excellent. Let's see. All right, everybody over here. So we're finishing up week number 5, and so we started last week. We talked about how to retrieve data, right, using select statements, select from where. We talked about views and using a group by, right, to create buckets and aggregate data. And so that was last week. This week we've been talking about how to update the data, right? How does the data actually make it into the database in the first place? So we talked about insert and update statements, delete statements, and we covered that on Tuesday. So we're gonna keep talking a little bit about that today. We'll finish up updating. We'll talk about the assignment a little more. And then maybe we'll get started on next week's functions and store procedures, right? After that, on week 7, the week after next week, right? The exam is coming up, and that will be on that Friday. So I guess 2 weeks from today, we'll have the first exam. We will go over. We'll have a review the day before, the Tuesday before that Friday. We'll go over some sample questions. We'll solve them here together in class, and you'll have that to review. That's a Friday after Dune comes out on Thursday, Thursday before then. So yeah, so that's we'll meet that Friday for that exam number 1. All right, very exciting. Any questions? Yes. Sorry. No, it'll be just like the quiz. It'll be just one really long quiz, right? And where you'll have a mixture of all the topics, right? All in that 1.5 hour. Very similar to what you've been doing. Lots of a lot of fill in the blanks, a lot of multiple choices, code that you have to complete to achieve a particular goal. Okay. Was there another question here? Yes. Yes. Yep. I'll make that available today. Did I make quiz 1 already available? I did. Okay. I'll make quiz 2 also available. Yeah. Thanks. All right. Excellent. Let's see. All right. I think we mostly finished the material for delete and update. Let's just real quick go over real quick. So we talked about delete, right? That's delete from a table, and that you can put a predicate. Actually, you should always put a predicate, otherwise the database is gonna complain. And so I just gave you a couple examples on using just Boolean expression to specify which records you want to remove, right? That you could use a select statement to choose exactly which items you want to remove. We saw that right, if you forgot, just like in delete, if you in the update, if you forgot the where clause, you would update all the records, which is probably not what you want. And so usually deletes and updates are always going to have some where clause, right? So here we gave you a couple examples on how to do that.
Professor, could you share your screen?
Ooh, yeah. Thank you. Let me share my screen here. Why is it not showing? Or I can't find my Zoom. Where is my share? Okay, there we go. Yeah, sometimes the UI Zoom is not very intuitive. All right, can you see my screen?
Yes, thanks.
We saw that you can also modify primary keys and foreign keys, you know, making sure that indeed it will let you make those changes. Interesting. It's not, okay. All right. So I think we did cover all that material. Well, all right. So let's talk about another somewhat advanced topic, and yes, I've mentioned that not everything that you can draw on a UML diagram is immediately implementable in SQL, right? We already saw a couple of examples of that, right? If you have a many-to-many, right, where you can have two classes that reference each other, and you say star star, right? That you can't readily just go in and implement it in SQL. Right? You have to first reify that and convert that into three tables or three classes, right? Where the intermediate class reference the other two. And so you convert a one many-to-many into two one-to-manys. Yes, that's the whole point of reifying. Well, actually, that's one example of reification, right? Of converting something conceptual that you can very easily draw on a napkin. You know, that if you want to convert that into something concrete, well, you'll have to tweak it a little bit so that it can actually be implemented. Yes, right. And there's a lot of examples of that where the target language or the target technology just doesn't support, you know, a very conceptual idea, right? That it doesn't matter that you can understand it in your head, right? Making that a reality in code has its challenges. Well, here's another challenge: inheritance. So inheritance is a very common concept in object-oriented programming. Yes, we will think about it as having a base class, and then you have several derived classes, right? Or we think about it as a parent class and its children, right? And the idea that we're trying to implement here is that the base class is a generalization of the more specialized children, right? It's just another of many mechanisms that programming languages give us to implement different layers of abstraction, right? So that you can think about very complex problems in terms of, you know, more simpler concepts, right? Or few of them, few simpler concepts, each one of which could also become more and more complex, right? So we like to think about, you know, in big boxes, and then you could look into that boxes that has, you know, some smaller boxes, and each one of those boxes you open it up has more detail and more detail and more detail. Yes, you know, functions is another example that allows you to build, you know, programs into, you know, small functions that you can get put together to make a bigger function. You could put together into a bigger function, like Legos, right? So inheritance is another mechanism for reusability, right? For having a division of concern. And so it's very easy. Most object-oriented programming languages support this, right? You create a base class, and all the other ones you can just extend or implements or inherits from, right? You know, most languages, object-oriented programming, support this idea. And the idea that we have is that all the base classes define the things that are common to all the subclasses, right? So for instance, if you have here an example of questions, right? You're going to capture questions, then you realize that there are many different categories of questions, right? There are questions where you have a true/false question, or you have a fill-in-the-blank question, or you have you know, multiple fill-in-the-blanks, right? You have essays, you have all sorts of types of questions. Yes, and you could, you know, if you apply good software engineering, you break it up into different tables, right? You normalize the database, right? Because there's some things that are common to all of them, and some things are very specific to the tables, right? So in object orientation, you would do maybe something like this, right? All questions have a description. They all have instructions, right? They all have the points. They all have maybe the score that a student got in that question. Yes, they all have those things, but some of them have things that are specific to that type of question, right? The true/false question might have, the right answer, whether the answer is the correct answer is true or the correct answer is false. But only the true/false question has that. No other question has it. Yes, right. And same thing with fill in the blanks. You might have the, how many blanks there are and what are the correct values, answers for each one of the blanks. Yes, right. But that's specific to the fill in the blanks. Okay, and so on and so forth. But they all share these features, right? Points, description, instructions, title. Right. So it makes no sense, right, in an object-oriented implementation to replicate these fields, to replicate them again for the fill in the blanks and the true/false. Right. That's just bad. That would be just bad software engineering. Right. You make a base class and it has all this. Make sense? Right. Well, there is no equivalent mapping of this idea in SQL. Right. So how would we go from this conceptual idea into actually implementing it in SQL, right? Well, we're going to consider 3 different ways of doing it, right? And this is often the case. It's often the case that if the target technology doesn't support the source, right, then usually there's some kind of compromise. There's some kind of decisions you have to make. Says, well, we could do it this way, we could do it that way, right? Imagine when we just had plain old C, and there was no C++. You could still write an object-oriented program using just plain old C, right? You just have to be very rigorous on using arrays and on using pointers and using, right? You could get away and write an object-oriented program even though the language didn't support all these object-oriented concepts. Yes, but obviously, some people might have one strategy, some other people might have other strategies on how to be so object-oriented in a non-object-oriented language, right? Same thing with old versions of other languages, right? So here we're going to choose 3. We're going to consider 3 different ways of implementing inheritance, right? In a language, in a technology that doesn't support inheritance. Okay, so there's three. Well, there's actually 4, but we're going to consider these 3 general strategies. One of them is called the joined, right, or the normalized strategy. Right. The other one is a single table, also known as the denormalized strategy. We'll see that this is what most people think of as being the most intuitive mapping between an object orientation inheritance into a SQL. Right. Everybody will think that this is the most intuitive. We'll see that there's a couple of problems with this implementation, right, and which the denormalized solution solves some of those issues, right? In particular, performance. This is very intuitive, but it's very bad performance, right? This one is a little less intuitive, but it performs the best. Right? And then there's one that it's a hybrid of the 2 ideas, right? And we'll see that each one has its pros and cons. But again, there's no best way. It depends on what it is that you're trying to do. All right, so let's look at the first one, the joined, also referred to as the normalized way of implementing inheritance, right? Okay, so the normalized way of implementing is that we're going to create a table for each one of the classes. So we have the base question class, yes. Then we have the true/false type of question. That's a specialization, and then we have the fill in the blanks. Yes. Well, 3 classes, 3 tables, right? In the first table, in the base class, right, in the question, we're going to create a questions table. I call the joined base question, right? Just so that we're reminded which strategy we're using, the join strategy, and which class are we creating, the question class, right? And it's a base class, right? So just to remind us what strategy we're using it. And we have the primary key and the auto increment. That's fine, perfect. And then we have the 4 fields from here, right? Title, points, description, and instructions. with the correct data types, right? Varchar for the description instructions and the title, and then the points is just a plain old integer. Right, so this is perfectly reasonable. All right, there's nothing magic about this. But what do we do with the other two? The other two are inheritance, right? They're inheriting from this table. Okay, so what we're going to do is that in this table, just like the class says, there's only one attribute there, right? That is true. It's Boolean, right? And we just created the way it's defined, right? Is true, and instead of Boolean, we use tiny int, right? Tiny int is the appropriate way of modeling Boolean expressions. Yes, and we declare our ID just like we had in the base class. We declare an ID just like in the base class. It is a primary key, but not only is it a primary key, but it's also a foreign key to the base class. Right, so there's a one-to-one relationship. And we might even put in here, which I didn't. We might put it also here a cascade delete. A cascade delete. And the intention here is that if you want to say you want to render, a UI needs to render the true false question. Yes. Well, it's going to need whether it's true false, so it can grade your question. Yes. But it's also going to need the title of the question, the description, the points, right? Everything that the parent record has. Yes. So it will need to join this record with the parent's record, right? To recreate the whole question. Make sense? Right. So really, the question is a collate. It's a collate, right? It's a join of this record with the other record. Make sense? To recreate the original record, right? And because I have a foreign key to my parent, I can recreate that question. Also, the cascade delete, which I don't have here, kind of tells me that these two records need to exist together, right? If the other one doesn't exist, well, it makes no sense that this one exists. Right? It makes no sense that I have an is true, but I don't have the parent. Okay, so if the other one gets removed, it should cascade to me as well here, right? It should be removed as well. So they should be considered one and the same. That's why we have the one-to-one relationship between the base and the derived. Okay. Similarly, with the true fill in the blank version, same thing, right? We only have the variables here, and we have the primary key, which is also a foreign key. So there's a one-to-one, and I would put here also the cascade delete. Make sense? Right. An example on what the tables might look like, right? You would have the base questions, right? So in the base questions, you might have 3 records, right? And with the descriptions, the instructions, how many points, the title of the question, right? And whereas in the other two, right, in the true false question, you might have one. So there's 3 questions in total. 3 questions in total, and one of them is a true false question, right? And they have the ID, which is referring to the 3rd question, right? That it's declared in the other table, whereas this one is referring to question number 2. And I would join them, right? I would join to be able to recreate the original question together with the points and together with the title, right? So this is very, very reasonable implementation, right? And it's by far the easiest to understand, right? 3 classes, 3 tables, right? And they're joined, right? Each one has its own set of the part of the original object, right? Half of the fields are stored in one table and half of the other fields are stored in the other table, and you need to join them. It's very reasonable, right? So if you need to retrieve the true false question whose ID is 234, right? You're going to fetch the yellow fields from the base table. You're going to fetch the blue fields from the derived table, right? Right, and then you just join the foreign key with the primary key of both of them. Very, very reasonable. Same thing with the fill in the blanks, right? You just get some part of the question from one side and the other part of the questions from the other. All right. Okay, so the great thing about this strategy is that it's intuitive. It's very easy to understand, very easy to implement. There's no redundancy. It's fully normalized, right? So there's a table one table for each one of the parts of the question that you're going to store. There's no redundancy. Excellent. The problem, right, is that it can become very slow, right? In this case where you just have one level of inheritance, well, you're going to have a join between these two, right? And that's fine, right? That's reasonable. But the thing is that in large object-oriented programs, actual programs, right? It's very, very common that you don't just have one layer of inheritance. You might have 2, 3, 4, many layers of inheritance, right? Where you have one base class, several subclasses, right? And each one of them having other subclasses, and that one having very much subclasses. I mean, depending how how the architect who designed this, right? How granular they want to make the data model, right? How much software engineering they put. Maybe it's over engineered, okay? But it's not uncommon that you have 3, 4, 5, 6 different layers of inheritance. Yes, right? And so to implement, to map that data model, that object-oriented data model to a relational model, okay, that would mean that you would have to create tables for each one of these classes, and that if you try to find an instance of an object in the second layer, well, then you just have to join with the table of the previous layer, right? There's just one join. But what about somebody who lives in the second layer or in the third layer, right? You're gonna have to join all the tables in the chain. See that? Right? You have to join table A with table B with C, D, all the way down the chain. So you remember, right? That's every time you do a join, that's a bump in the time complexity, right? If you go from one table to 2 tables, it becomes n squared. If you go 3 tables, it's n cubed. If you go 4 tables, is just keep going. The complexity grows exponentially. Yes. So even though this is very intuitive, it's very often not the way folks go to implement this. Right? Instead, they do the following. They apply this other strategy called the denormalized strategy. Okay, where instead of having multiple tables for each one of the classes, they have one big table. Right? They have one big table where they're going to have all the classes living together in that one big table. Okay, which is everything we've told you not to do. Right? We've told you not to denormalize. Okay, right? And again, this is being done, on purpose, for a particular reason, right? For, in this case, it would be for performance issues, right? And everybody's on board as a software engineers that everybody's agreed to do this, right? And usually it's done through the use of views, right, or materialized views, where it's you don't actually do this yourself manually. You're not going to touch these tables yourself manually. Usually it's through some application, right? An application is doing all the joinings for you, okay? And it's guaranteeing that you don't have redundancy through the application level, okay? So anyway, so this implementation would be as follows. Instead of having 3 different tables, one for the base class and then 2 for the derived classes, we're going to put everybody in a single table, right? So notice that here we have the original 4 fields that were for the base class, right? And these are the 2 other fields that were for each one for the derived classes. See that, right? And now a particular record in this table, well, one record will be for a true/false question, and maybe another record will be for the fill in the blanks questions. Yes. Right, that means that for the record that is for the true/false, you'll have a value for the is true, but you'll have a null for the variable, right? Because it makes no sense that in a true/false questions you have a value for the variables. That makes no sense, right? Right. So and vice versa, right? If you have in a record that is for the fill in the blanks, you have a value for the variables field, but you won't have a value for the is true. It'll be null. Okay. So it's very common that in this approach, you'll end up with very sparse tables, right? Where you'll have a certain fields like these over here, the ones that are shared amongst all the types. Yeah, you'll have values for all of them, right? But where you get to the fields that are specific to each type, you'll only have values for that type. And all the other columns are going to be empty, null, null, null everywhere. Okay, and data analysts or database DBAs, hate that, right? When you have tables that are very sparse, that have all this empty spaces everywhere. Okay, and because you're just wasting space, right? And this is where the compromise comes in, right? What you're trying to avoid here is avoid the X joins, right? Having to join 2, 3, 4, 5, 6 tables in a very long inheritance chain, right? You're trying to so what you're doing is compromising time for space. It says, okay, well, time is much more expensive than space. Space is very, very cheap. There's lots of space, right? And it's but time is much more valuable. So I'd rather waste space, right? If I can have more performance. Make sense, right? And so again, this would be part of a long discussion with our DBAs that this is exactly what the engineers want to do. They're fine with wasting all this space. Okay, and it would be a long discussion about this. Make sense, right? So yeah, so this is referred to as the denormalized strategy. Everybody good? Okay. Oh yeah, and additionally, there would be an additional field. There would be an additional field, okay, that was not in the original classes, but usually it's called type or D type or something, right? That is going to let us know how should we interpret this record. Should we interpret this record as a true/false question, or should we interpret it as a fill-in-the-blank question? Yes, and it would be usually they use the name of the class that was originally used to instantiate the object, right? So if true/false class was instantiated, that they would use that as the name here, right? And then the application would use this as a key to know, right, how to interpret that one record. That if that one says true/false, then it should read the values for true/false and ignore the values for any of the other classes, right? And vice versa. If it's fill in the blanks, then it should look at the fill in the blanks variables, but not the other ones. Just ignore them. Make sense? All right. Yeah, this is by far the strategy that is mostly used in industry. You'll see lots of those. And again, it was a deliberate decision by the architects, right, to do something that normally we would not do. Normally, we would discourage you from denormalizing the table. Okay. Right. So retrieving a question is trivial, right? You just do from a single table. There's no joins. So this is by far the fastest performing. Right. Now there's an intermediate, right? There's an intermediate strategy that kind of marries these two ideas together, right? It says, okay, well, it was intuitive for me to understand that each table had a class associated with it, right? One class, one table. Each class has its own table. Yes, right. So that was intuitive, but I understand the problem of joining. So how could I marry those two ideas? How could I marry the idea of, yes, I want a table denormalized, right? Having all denormalized, each class gets one table, but at the same time, I avoid the performance of joining, right? So the table per class strategy, borrows this from the best of both worlds. Yes, it's going to have one table per class, right? And the way it's going to avoid the join is that it's going to literally, right, bring down the fields from the high level classes. Is going to bring them down to the bottom level classes, right? So that, and it will store the data. It will store the data at that one table, right? So that So let me show you, right? So if you had the well, you have the base class, right? There it is, all by itself. But then the next one down, right? If you talk about the true false or the fill in the blanks, right? What they're gonna do is like they're gonna copy the same fields that were in the base class. They're gonna repeat it again at the bottom, right? So we're gonna do something like this, right? In the oh wait, base, okay, yeah. So here's the base class, and then to implement the true false, we're gonna repeat the same fields that we had in the base class, right? And we're gonna add the additional field. That means that as you go deeper into the deeper lower hierarchies of the inheritance tree, right? The corresponding table is just going to accumulate and get bigger and bigger and bigger, right, in the fields, right? So that you get the same fields from your parent plus yours, right? And the one below you gets the one from you plus theirs, right, as you go follow down. And then when you store a record in there, it will have the values, right, stored already in your record from higher levels, right? So that you don't need to join, right? You don't need to join from your parent because the data is already in your record. See that, right? So you avoid the performance of joining because the data is already in your record. So we kind of like pre-joined when we stored. Right? So basically what we're doing is that we're joining when we're storing as opposed to joining when we're reading. See that, right? We pay the price when we insert, okay, so that we don't pay the price when we do the read. See that, okay? So yeah, so if we're going to insert into the true false, we would insert, the description, the instructions, the points, the title, the is true inside of the true false question, as opposed to putting, half of the fields the base class and half of the fields in the true false, right? It all goes in here. We don't repeat the same information in the parent one, right? We only store it exactly at the level that you wanted, so it's already there. Okay, it's a little bit like when you do hashing, right? That when you store information, you store it exactly where you want it, so that when you retrieve it, there's no search, right? It's constant time search, right? So this strategy, same thing for fill in the blanks, right? We have variables. We're storing information about both the base class and the derived class all in the same record, right? So that we don't pay the price when we retrieve the data. There's no joining. Okay. All right. Yes. Yeah. No. This has the same cost of space of the previous one, the one we had earlier, but it's more intuitive for the DBAs of having this broken up into multiple tables as opposed to one big table, right? And you can better index these, so because the values are specific to that one record, and it improves performance like that, as opposed to sparse tables are harder to index. You have all this empty space. Yeah. All right. All right, so let's talk about a couple more things. Okay, so whenever we are dealing with lots of information, right? Typically, we don't deal with it all at once, right? We usually consume the data in chunks, right? So, for instance, whenever you do a query and you do a select star, from a table, and that table might have thousands, hundreds of thousands, millions of records. Yes, okay. And when it displays it in your user interface, right? Usually, it will only display maybe 100 records at a time. Yes, even though, right, logically, you are looking at all the records, right? It is presumably aware of there being millions of records that meet your query. Yes, but you never actually consume it all at once. You only consume 100 at a time, 200 at a time, perhaps, yes? And then you do scrolling, right? You scroll down or you paginate or whatever, right? And same thing with the application, right? The MySQL workbench, right? Can interact with a database that is terabytes huge, right? But your CPU can never instantiate all at once terabytes of information in its RAM, right? Could not possibly, grab all that information, put it in memory, and then render as a user interface rows that you can paginate. Yes, so it too needs to make a mechanism that allows it to cache or consume content, few records at a time. Yes, right, so let's look at mechanisms by which we can achieve similar features, right? So one of the ways that we can implement these kinds of features that now you see them all the time, right? When you whenever you have a query either in Google or any search query, usually it'll give you, I don't know, 20 results, right? And then it allows you to just paginate, go on to the next page. Yeah, next page, and then it shows you the next ones or the next ones. I think Google had at some point, I don't see it anymore, like in the UI where as you start scrolling down, right, it would make additional queries, right, to fill in the blanks as you scroll down. I think Google Photos does that. So, right, as you keep scrolling, they'll do more queries and fill in the blanks and give you the illusion, right, that it's an infinite scrolling UI, right? But you always have to deal with the fact that, hey, I need to cache this somehow, right? And I'm gonna end up not having enough memory, right? If I keep reading, I need to release all the other 10 records that I had originally, just throw them away, right, to make space for the next ones, right? And give you the illusion of this infinite, infinite scrolling. Same thing with Google Maps, right? It allows you to drag and move it around and flick it, right? But obviously it doesn't have the whole map all at once, right? As you drag, it keeps searching the next layers, right, to paint it as fast as it can, right? So how do we do that? No, we need to be able to work with chunks of data at smaller chunks of the whole thing. Anyway, the SQL provides some commands that allow you to do that, right? So for instance, the top command allows you to say, well, there might be thousands of records, but I don't want to look at all of them. I want to look only at the first 10, say, okay, or the top 20 or the last 20, okay. So you can provide either a specific number that you want to look at only 20, 30, 40, 50 records, or percentage, right? I want to see half of them or a quarter of all the records, right? And so you can add that to your select statements, right? And use and implement kind of like pagination, right? Like 50% or top 2, right, records from a table. Okay. So here's an example where you say, you have 4 records, you say top 2, you come back with the 2 records down below. Another way that it allows you to do is limit, right? MySQL MySQL allows you to provide, say, well, I want to limit my response and say, just limit it only to 10 records, right? You can also skip. You can say, you're starting from record number 10, give me the next 20, right? That's where you could easily create a pagination where you can start at page whatever, right, and then give you the next 10 records, right? So limit allows you to do that kind of thing, right? So whatever comes back, I want to see only the first 5 in that result set. Oracle has something similar, but they use what is called row num, right? And the name says it all, right? It's considering the order of the row, okay? The order of the row. So whenever Oracle, you do a query, and when it comes back, in the result set, Oracle assigns a number, right, to each one of the rows, right? The first row, the second row, the third row. This is the resulting row, not the row stored in the database. Okay, there is no order in the database, right? It's whenever you retrieve the data and you have in the result set, you might come back with 100 records. right? So there's the first row, the second, and the third, and so on and so forth. You can achieve similar results with row num in Oracle. The problem in Oracle, though, you have to be careful, right? The way you use row num, right? Because it's only calculated after the query comes back, right? When it comes back and say, okay, well, here they are. There's the rows that came back, and well, the first one is the first one is 1, 2, and so on and so forth. Okay. So for instance, one of the problems is if you say row num greater than 1, for instance, because you could say row num less than 10, then that means then, okay, fine, the results come back. I have 100, but I only want the row nums that are less than 10. That makes sense. 1, 2, 3, 4, all the way to 9, right? It doesn't include number 10. So it throws away all the other ones. That's fine. But this one makes no sense. If you say row num greater than 1, what does that mean? Typically you would say, okay, well, that would probably mean that I want to skip the first row and I want to see all the other ones, right? Or you might say row num greater than 10. Okay, that means usually you would think, right, that I'm skipping the first 10 rows and I want to see all the other ones. But it doesn't work that way because row num only makes sense after the rows have come back. But by the time you get here, there are no rows because I haven't identified them because the where hasn't executed yet, right? So there are no row numbers, right? So this would not return anything because I haven't identified those queries, right? So instead, what usually when you want to achieve these kinds of things in Oracle, you would have to combine into 2 queries, right? An inner query that calculates the records that you want, right? Where you have the where clause, right? Employees who have make between $50,000 and $100,000 comes back with 20 records, yes. And then the outer query, you can say, okay, now that I've identified the records and I have the row numbers, okay, I only want the ones that are between 2 and 10. Yes, right. But in this over here, it doesn't execute because again, I haven't yet calculated the rows, so there are no row numbers. You have to just be careful when you use it in Oracle. Yeah, so same thing, right? Row number between 1 and 5, it doesn't work, right? So here's an example on how you might go about it, right? Or just to illustrate the problem in Oracle, right? You have these folks, right? Clara, Deborah, they're all Smith, and the row numbers that come back, right? So select all the first, the last, and notice that you can use row number itself as a field, right? That is calculated on the fly when it comes back with a query, right? And you can say, first, last row number where the employee last name is Smith. So there it is, right? You have the row numbers. There's 10 of them. Okay. Now where you have this last here, right? Seems to work fine. So let's see what the problem is, right? So it's a row number between 1 and 5, right? Last name is Smith, right? But right, if you keep querying it and you start ordering, when you start ordering by location, you start looking at the row number is broken, right? Because the row number was calculated in the previous query, right? So when you come back here, you would expect that the resulting would be that the row numbers are still 1, 2, 3, 4, 5, right? But they were already assigned in the query of doing the where last equals Smith, right? So that and you would have expected that the result would have recalculated the row numbers to be again 1, 2, 3, 4, 5. Right? So you can't rely on row number because it was calculated only in the first query and not re-updated later on. Whereas limit, right, in MySQL and limit also in SQL Server, right, would behave the same way. This would always be the first one. This would always be the second one. This always is the third one. Right? Whereas row number is not. Right? You have this 1, 6, 4, 8, and 5. Right? It's the original order that came out, right, that calculated the row number, and it did not recalculate the row numbers after you order by or you do some other operations. And that's a problem because now if I say, well, give me the first 3, right? You can't rely on the row number anymore. Okay. So the So yeah, so you come back with, give me the first 1 through 5, you get 1, 4, 5, 3, 2, which is not in the original order that I wanted it. Okay, so the fix, as I mentioned earlier, is to have several, or at least two queries where you first calculate the actual computation, the actual query that you want, without where you calculate the original row number, right? And then the outer one, right? You can then keep using the row number for additional things such as the where between. Okay, so you first force the calculation of the row number, and then the additional ones can assume that the row number has already been calculated correctly, which is unfortunate, right? Because SQL Server and MySQL don't have this problem, right? You just use limit, right? And limit always assumes that the first one is the first one, the second one is the second one, right? And it recalculates all the time, right? It doesn't have this initial row num that doesn't get recalculated, and it's a pain, right? Which is unfortunate, right? Since Oracle is a pretty cool product. Yes. So in MySQL, you just use limit. You start at X and it goes to Y, and it'll always behave the way you would expect it, right? It's whatever comes out, it's starting at 5 and going down to 10, right? And yeah, and you can use both in MySQL and SQL Server. Yes. Yep. Okay. All right. Excellent. Oh, the assignment. Did we go over the assignment? DB5? We did. Let me make sure. Right, so this is asking you to download the database, and it's the same database that you had from the previous assignment. If you broke it, if you did anything to it, you can re-download it again, right, and just restart from whatever we give you, okay? And then it asks you to do some updates, right? Insert using the multiple columns, and then just giving the column names and the values. Insert Frank Herbert, that his movie is coming out the 21st, and with just the fields with no name for the columns. Depending on the order of the tables. Then I think we ask you to also copy, and we show you an example of a copy where we copy into the blogs, right? We also create a table called the unliked posts that queries the posts and into a new table called the unliked posts, right? Looking at the whether the liked is true or false, right? If it's true, it grabs those records and it copies them into the unliked posts. I think it does it for liked posts. Yeah, liked posts. Now you try it. You create a liked post, and then you're going to do a query that's going to copy from the posts. It's going to look for the ones that are unliked, or sorry, liked, right? It's going to copy them into this table. So you do the query on your own. Then you play with updates and play around with deleting. Okay. All right. Was there any questions? Did anybody get started on this? Not yet. No. Okay. Well, again, I have office hours at 5. If you want to join, it's 5:30. Sorry, 5:30. If you want to join, we can take a look at it. All right. Excellent. Let's start talking about some more interesting topics. Not this one. Yeah, I don't want that one. That's this one. Not that. All right, store procedures. Okay, so yeah, we saw that we were talking that some things cannot be done with just plain old SQL, right? SQL is very declarative. You declare certain constraints. You say that this is a primary key, it's a foreign key, right? And that and this is a character, and this is an integer, and there's a foreign keys and primary keys. Yes, and that you can combine primary foreign keys to enforce rules. Yes, and you can declare all these things, but there's a limit of what can you do, right? To enforce. Oftentimes you could to be able to enforce certain rules, you have to break other rules, right? And sometimes they're mutually exclusive. You either do referential integrity or you enforce a business rule. Okay, so oftentimes we need the full-blown expressive power of a programming language, right? You can have all sorts of branches and loops and where you can make the explicit logic of what actually you want to happen, right? Or validate before you let information get stored or retrieved or whatnot. Okay, so that's where store procedures come in, right? So store procedures is going to allow us to use a full-blown programming language within the database, right? Each database has a full-blown programming language that is specific to SQL, right? Where the data types, obviously you have all the primitive data types of varchar and integers and booleans and whatnot, right? But just like in object-oriented programming languages, you have classes and inheritance that have things that are specific to that technology stack. Here in the relational world, you can operate on data types that are specific to databases, right? Such as tables and records, right? And just like in C++ or Java, you can instantiate pointers and instantiate classes. Here, you're going to be able to put inside of loops and logic. You're going to be able to put inserts and updates and deletes, right? So that you can put in a loop. I want to generate dummy data, and so I want to loop for 1,000 times, insert this random set of data, right, and just populate my table with garbage, okay? Or just iterate and do all sorts of operations on the table. Very, very powerful, right? So that's what we're going to be spending in the next couple of weeks. So this week, we're going to be spending, starting Tuesday, we're starting today. We're going to be using store procedures where you create programs inside of the database that run in the database, okay? Using language that are specific to MySQL, SQL Server, Oracle, whatever, right? That run inside the database. So that's today and all next week. And then we're going to take a look at being able to program the database beyond the database, right? Where you can interact with the database with outside programs, right? Like Python or Java or C#, right? That now you have a full-blown use of very, very advanced programming languages with you're completely unrestricted from the database, right? So where you can have your entire application, but it can talk to the database to do all the storage and data retrieval and whatnot. Yes. Right, so there's these two strategies. One where you program in the database, but also you can program outside of the database. Right. So first we'll look at programming in the database. Yes. So there's some pros on programming the database. Is that well, you cannot be closer to the database, right? The data is right there in the database. You are running as part of the thread, right, inside of the database. So it is the fastest access you're possibly going to have to the data, right? And the fastest you can run with the raw data, right? As opposed to if you're running on Java or C# or outside of the database, well, that's not as fast, right? Because you're not running in the data. You're running a completely different process, right? You would have to rely on network communication or multi-threading, blah blah blah, which is never going to be as powerful and as fast as running in the database. Yes. One of the cons, though, is that it's yet another language to learn. Okay, it's another programming paradigm, right? It's another piece of source code that you need to maintain and run quality assurance. Yes, right, and people that are trained in that specific technology, as opposed to it's easy to find folks that know Python or know C# or whatever. It's hard to find people that know how to program a database, right? So that's also pros and cons, right? Yeah, hard to maintain, right? It also complicates migration, right? If you start coding using the program language of your particular vendor, right? Say Oracle or SQL Server, and you ever went away, well, not only are you going to have to port the schema, right? And you're going to port the data, you're also going to have to port all those algorithms that you wrote for that particular vendor, right? So it complicates the migration process as well, right? So yeah. Also, it's an additional burden on the database. So not only is the database now answering queries, right, where you have hundreds of folks sending queries to the database, and it has to do all the joins and all the right and what to come up with the result sets and send them to folks. But it also now has to run these programs, right? It has to execute all these stored procedures, right? So it's more cycles on the CPU that is running your database, right? So anyway, there are 3 types of things that can execute in a database, right? And they all have different things that they can do. The first of all, there's functions, right? And like a function, they behave just like a function. You think, right? You pass it an argument, right? It runs some algorithm, and then it comes back with a result. Yes, right? That's what we mean by function. Now, there's certain things that a function can do and it cannot do, and where is it meant to be used, right? So it cannot change data. So within a function, you could not, for instance, do an update, right? Run an update or do an insert into a table, right? You would run an algorithm, calculate maybe the average of something or add up the values. You can do a select. You can read all you want from any tables, do all sorts of joins, iterate over the row set, right? Do an average, whatever, right? And then come back with a value, right, from the function. So yes, you cannot change the data, but you can certainly read the data. It always returns some result of running your algorithm on the data that you passed it, right? And usually you call it as part of some statement, right? Where you say, find me the select the employees where salary is greater than, instead of putting a hard-coded value, you can have a function, okay? And the function might be called hired this year, or hired, and then it takes it as an argument the year. Yes, okay. Then the function would run, right? Do the blah blah blah, do all the queries. We'll come back with the results, and now you can use it as part of your greater than or less than. Make sense? Right. So it's meant to be used as part of a statement. Then you have a store procedure, right? Procedure it's kind of one of the more powerful ones. Is that it's just a general purpose algorithm, right? That you usually run it from the command line, right? It could be like a script that you can run, like a batch script, right? That you might run every week, every morning, right? As in maybe it's a health script, right? That makes sure that there's no duplicates. It finds where there are inconsistencies and generates a report for you. Yes, it can do all sorts of queries. It could update and clean up any mistakes, right? And you would run this batch. It can do inserts, updates, deletes. It can do. It's the most powerful thing, right? It can return data if you want it to be as a result. But typically, it's used because you're going to change some data, right? And you can do some maintenance, right? And usually you execute it from the command line, right? Not part of a select statement, not part of a from, not part of a where, right? It's something you would run from the command line, right? Like a batch script. Then you have triggers, pretty cool, right? Triggers are algorithms that execute when some event happens, right? That's why they call triggers, right? So for instance, you might put a trigger on a table, and you say, okay, well, this table, right? If something happens to this table, I want this trigger to run, right? If somebody inserts something into the table, I want this trigger to run, right? If somebody should delete or update or select, I want these triggers to run, okay? And these triggers can can be, can be used for all sorts of things, like for auditing purposes or for validation. Right? If somebody inserts something into a table, the trigger runs, right? And the trigger can look at the record that you're trying to insert, right? You can take a look at it and says, "Ooh, this is no good. This record is garbage," right? So I'm gonna avoid it. I'm not gonna allow you to insert this. This is garbage, right? Or the trigger might try to fix it, right? And see, oh, well, this email or this date is not formatted correctly. Let me fix it up, okay? And once it fixes it, then it says, okay, well, now we have the correct version of the record. I'll let it through, right? And then I'll let you insert it, right? Right. So, or if you insert some data and you says, okay, well, this faculty has been the role of system administrator, yes, right? And then it can see that there's an insert into the roles table, yes, right? And the trigger can say, oh, well, if this faculty has been given a system administrator, well, then they should have these other pages, right? And do all sorts of inserts in some other tables and do updates everywhere, right? And make sure that you have the correct privileges in other different places, right? So these, just by inserting and updating one table, right, you can have all sorts of very complicated rules to go on and update other things that happen. Yes. So yeah, so very, very powerful. It's event driven depending on what is that happens, either an insert, update, or delete. Right, it doesn't return data, right? It can veto a command or not. So let's take a look at a couple of really simple examples. So first, let's take a look at functions. Right, so functions. Right, so the way we create functions is with the statement create function. Right, create function, and you give it a name for the function. Right, the pointy brackets here are not necessary, but it's common to use the quotations. And then you can put it in parentheses any optional parameters that you might pass it. Okay. Right, and then inside of the function, you put the begin and end where you're going to put your code. Right. Yeah, cases not it's case insensitive. In a function, you cannot do any of the schema manipulation. So you can't do like a create table or alter a table or drop tables. You can't do that, right? Only selects, updates, deletes, right? Well, actually, in a function, you can only do select. You can't even do a insert or update. Okay. The delimiters are not going to be relevant to us, but in general, if you're using Workbench, right? Workbench is nice UI and whatnot, right? But usually, if you're using a non-UI client to interact with SQL, right? Usually, it's expecting you to type select something or insert or update or delete, right? Where you put a semicolon and it runs the command and it gives you a result set. Yes, that's typically how you interact with databases with a non-UI. Yes, so to allow developers to create a function. Functions are going to allow you to wrap all these select statements with the intention of being executed later, right? When you run the function, yes, right? You want to be able to write a function that says, okay, well, the function is retrieve all the employees, yada yada yada, and you're going to use this select and this update and this delete. But those commands are not meant to be executed right now, right? They're meant to be executed later when you run the function. Make sense? Right. So the database needs to be able to distinguish on whether you're telling me and you're declaring a function, meaning all these select statements are meant to be postponed for later, right? Or whether you want to run it right now, right? So the way you do that is by changing the delimiter, right? The delimiter, meaning usually semicolon means execute this command now, right? And give me the result, okay? But we want to say, no. Don't interpret the semicolon as execute now, yes, right? So what you can do is change the delimiter, and you can change to whatever you want. And for instance, change it to // meaning do not interpret a semicolon as an execute now, because I am creating a function, right? Once I am done, I'm going to do a // meaning I'm done with the function, execute it, create the function so I can run it later, right? You can change the limiter back to a semicolon, okay? We won't have to do that because we're going to be using a UI, right? The UI is going to do all this for us in the background. But just to understand that if you see delimiter, you'll know what it means. All right, so to create a function, it's easy, right? When you have a schema, you have your tables, right? You have your tables, your views, you have stored procedures, right? Which we're going to use in a minute, and you have functions, right? And you're going to create a new function. You say create function, and it opens up a table for you to start coding, right? Not table, a new window, right? And in that window, this is what you get. This is where you say, create function, new function. You can change the name of the function, right? By default, it returns an integer, and by default, it puts a return 1. Yes, so it creates the simple body for your simple function, and this is where you code. This is where you put your code, right? So let's create just a really dumb couple functions just to get us going, right? So let's first just add 2 + 2. All right, that's trivial. So you do something like create a function, you name the function, add 2, yes, and it returns an integer, and it's going to return 2 + 2. Make sense? You apply, and then it writes for you the code that you would have written at the command line, right? It notice that it goes and says use DB design, right? That's the database that I had selected, the double clicked, right? It drops the function if it already exists, just like if you were creating a brand new table, right? It first drops the table and then recreates it. It changes the delimiter to $$, meaning now the semicolon is no longer right? Notice in the first line over there, see that? Notice the semicolon still means execute this line, see that? In the second one, again, there's a semicolon at the end, see that? It means, yes, execute this. Now we change the delimiter to $$. And the reason is that within our function, we're going to have a $sign over here, see that? Right, but I don't want this to execute right now. Yes, I want it to execute later when I run the function, right? That's why the delimiter. So notice I say here, use DB design $sign here. See that? That's because now this is as if this were the semicolon, right? So execute this. So execute it. I do my function, yada yada yada, and as if this were a semicolon, right? This means it executes this create statement. It creates the function, and then it puts the delimiter back to semicolon, like it was before. Yes. Everybody okay? All right. Then it tells you, okay, is this okay? You say, yep, you apply, and now the function exists. Now the function exists. So how do we use it? How do we use the function? So remember, this functions are meant to be used as part of a larger statement, either in a select statement or a where clause, right? Compared against something, right? I can say, select blah 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 where, right? My salary is greater than 2 + 2, right? And I call the function. So here's a very simple. I can say just select, right, and add 2 + 2. So this comes back with the value with a 4, right? So this comes back with the result set. Add 2 to 4. 2 + 2 is 4, right? I could use it in a where clause too as well. Okay. So let's take a look at it. Just a smidge more complex function. Instead of hard-coded the results 2 + 2, it comes back with we can pass in arguments now, right? A and B being declared as integer both, right? Integers and integers. Now, right, it's just that you return A plus B. Now I can call it, right? Add AB 2, 3 comes out to be 5, right? Okay. All right, again, all these functions are only meant to be used as part of a larger expression, right? Either in a select clause, and a from, or an where, right? Together with an ands and ors in parentheses. Yes. Okay. Right. Something a little more. Here's another one, right? Where I can use now add a comma b in a larger table. So say we have this table over here, right? That has A, B, and C, columns A, B, and C with values 12, some characters here and some floats, right? Okay. Well, right, I could, if I do a select star, right, from B, this is what I would get, right? I would get that table there. Yes. Well, I can do something similar. I can say now, if I say select A comma B from B, I would just get, I would get this, right? I would get these two columns. Yes, everybody okay? I can add an additional, I can extend and create a brand new column. Yes, and give it a name, the name A plus C. I can say comma, add AB, right? And pass the values AC, and notice that it generates the addition of all these, 12 plus this one, blah, 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 all these, right? I could use this like for, if I have students with the first name and last name, I can calculate the full name, right? And the full name could have been the concatenation of the first and last name, right? Same thing, I could have done that. So that as opposed to denormalizing the table, right, I could use a function to calculate those kinds of things. Yes? Right, so yeah, we saw that we can return integers, right? We can return strings as well. Right here, we're returning the varchar, right? And we're returning a hard-coded string with hello world, or I could take arguments, right? Full name, it takes as argument first, middle, and last, right? It calculates the concatenation of all three, and it returns the concatenated strings, right? Okay, so that's functions. And yeah, let's stop here. We'll continue when we come back on Tuesday. If you can read through the stored procedures for Tuesday, right? It'll go. We can continue, and I want to jump as fast into the Java part, which might be challenging. Hi.
I have a quick question about
Yep.
the homework.
Sure.
So I have to prove that this part. I wasn't sure if I did it right. So this is like the sum of the likes, and then we were supposed to get the average scores.
Mhm.
I was wondering, does that mean get the average score for a post?
Or per post, yes, per post.
Okay, so I think I did it right. So for the post, I just did I just selected from the
Group by
post
post ID, okay, right, and then the average, right? So average adds them up and divides it by the number of. Yep, exactly.
Okay, cool. I was just
Yep.
checking. I was
Yeah,
confused.
perfect.
Thank you.
Yep.
Are the exams going to be?
Yes.
So just like you said, similar stuff as quizzes,
Yep,
just longer.
Hi, one other question. So, I'm a DS major, so all the work that I'm doing, in my DS related classes are in Python. Do I
Okay.
have to, learn